Hello everyone. Today we are going to discuss our fifth problem, designing the DFA for a language capital L equals to W such that modulus W mod 3 equals to 0. So let's start the fifth problem.
Hello everyone. Today we are going to discuss about how to design the deterministic finite automata, that is DFA, that accepts the language L equals to W such that modulus W means, here actually W means string W such that length of the string, modulus W means length of that string, modulus 3 means if it is divisible by 3, length of the string mod 3 means if you take a string length, if it is divisible by 3, if it is equal to 0, then that length should be considered as an input over an alphabet sigma equals to a comma b. So we have to design a deterministic finite automata, that is DFA, that accepts the language capital L equals to, if you take any string, suppose if you take a string called W equals to AAB. What is the length of the string? The length of the string is 3. So if you take any string which is of length that is divisible by 3, then that string should be accepted by our DFA. So the question can either be given as in the regular language format, that is in the roster form, that is capital L equals to W such that modulus W mod 3 equivalent to 0. If that is true, then that type of string should be accepted by our DFA. So the string should be formed over an alphabet sigma equals to a comma b. Means here whatever the strings you are taking, that should be a sequence of input symbols a's and b's. Okay. So the question can be either like this, or it can be given as the length of the string is divisible by 3. Okay. So this is our question. Now we will try to before designing the DFA, we will try to understand what type of strings we can take. So the length of the string, so modulus W mod 3, this equals to 0. So if I take W equals to AAB or BAA or ABA or only AAA or only BBB or BAB, any combinations of A's and B's, there is no restriction in taking the combinations of A's or B's, but the length of the string should be 3. So these are all the sample strings in which the length is 3, means modulus W is 3. 3 mod 3. What is 3 mod 3? Means if you divide 3 with 3, the remainder should be 0. That is 3 mod 3. 3 mod 3 is 0. So if this is equivalent to 0, then that type of strings should be accepted. This is our question. Not only 3, all the numbers which are divisible by 3 are equivalent to 0. Suppose if I have taken W equals to ABAB. What is the length of this string? The length of the string is 4. So if I take 4 modulus 3, means 3 divided by 4 means 3 ones are 3. Remainder I am getting 1 here. So if I am getting 1, then this modulus W mod 3. What is modulus W? It is 4. So 4 mod 3 is not equal to 0 because it is 1. So 1 is not equal to 0. So we can't take a string of length 4. We have to take the string which is of length which are divisible by 3. So same way I can't take 4, I can't take 5, I can take 6. Now let me take, it can be of any combination. So A, B, A, B, A, B. The length is 6. It can be any combination. It can be all A's also. It can be all B's. Or it can be a combination of BA, BA, BB, anything. But totally the length should be 6. So modulus W mod 3, if I take, modulus W is length of this string is 6. So 6 modulus 3 means if you take 3 divided by 6, 3 2 just 6. So I got remainder 0. So modulus W mod 3 equals to 0. So all the numbers which are divisible by 3, that length of string should be taken. Means I should take a string of length 3, 6, 3 1 ja 3, 3 2 ja 6, 3 3 ja 9, 3 4 ja 12, 3 5 ja 15, 3 6 ja 18, 3 7 ja 21, so on. So I should take the length of the string as either 3 or 6 or 9 or 12 or 15 or 18 or 21. So multiples of 3. So by understanding this one, I should able to take the length of the string every time. 3 means 3 is added with 0, it is 3. 3 is added with 3, it is 6. 3 is added, that 6 is added with 3 means 9. 9 added with 3 is 12. So like that logic we should consider while designing the DFA. So first the length should be 3. Again the length should be 3 added, you will get 6. Again the length should be added 3, you will get 9. So in that combination, if you try to take the strings, we can able to design the DFA very neatly. Okay. So now what we will do? We will try to design a finite automata for this. Okay. So now I have told you W equals to, that is length of the string equals to 3, 6, 9, 12, 3 5s are 15, 3 6 are 18, 3 7s are 21, 3 8s are 24, 3 9s are 27, 3 10s are 30, 3 11s are 33. So like that all our numbers are divisible by 3. Okay, so now first string, what is the sample string we can take? The sample string we can take it as ABA or BAB or any combinations of A's and B's, but the length is 3. This is our basic string. Now try to design a deterministic finite automata for this basic string. So I will start from Q0. Q0. So I should have length 3. So length should be 3. Q0, Q1, Q2. One thing we should remember, 0 is also divisible by, that is the multiples of 3. Right? So hence 0 should also be considered. 0 means the length of the string is epsilon. This is the very basic string. Okay, so 0 mod 3 if you take, it is 0. Right? See, 3 divided by 0 is 3 zeros are 0. So I got 0. So hence 0 mod 3 is also 0. So that if the length of the string is epsilon, then also our DFA should accept. So the very basic string is epsilon. So epsilon means generally our DFA shouldn't accept anything. So if epsilon is a string, then that corresponding DFA is initial state itself becomes the final state. So this is the DFA for a string epsilon. So our DFA should accept epsilon also because the length of the string is 0. So in that case, the initial state becomes the final state. So by this, we can tell that epsilon is accepted. Next is string of length 3 should be accepted. So I can take A, B, right? This is our string A, B, A. A should be ending up to the final state. So from Q2, I am ending to Q0 with A. Okay, now the length is 3. 1, 2, 3. Length we have understood. Now we will try to take the sample strings. It can be, see, first string can be A or B. So I can take A comma B here. Okay. Second string can be either B or A. So I can take B comma A. Third string can be A or B. So I can take A comma B. So this is the DFA in which it accepts the string of length 3 right now. Length 3. If I take ABA, A, B, A. If I take BAB, B, A, B. If I take 3 B's, B, B, B. So any combinations of A's or B's or taken, there is no restriction that first symbol should be A or last symbol should be B. There is no restriction for that. So we can take any A's or B. So I like for Q0, I can take transition with both A and B. Only the constraint here for this DFA is the length should be divisible by 3. So right now we have 3. Okay. If I want 6, length 6, 1, 2, 3. Okay. 4, 5, 6, ending up with 6. 7, 8, 9, ending up with 9. 10, 11, 12, ending up with 12. 13, 14, 15, ending up with 15. See, all multiples of 3 are ending to 15. If I take 4, 1, 2, 3, 4, ending to non-final state. Any other length of the string, the number which is not divisible by 3 shouldn't be accepted. Now, if I take A, only A, this is 1. Length of the string becomes 1. So, 1 shouldn't be accepted. From initial state, it is going to Q1 means it is ending up to the non-final state. Hence, this is not accepted. If I take A, B, then the length is 2. A, B, ending up with non-final state. Hence, the string is not accepted. So, any combinations of A's or B's, if the length is 1 or 2 or 4 or 5 or 7, 8, then the string will not be accepted. Only the multiples of 3 or the numbers which are divisible by 3 should be accepted. Now, if I take a string length of 9, it can be anything, not only A, it can be B also. A, B, A, B, A, B, B, A. What is the length? 1, 2, 3, 4, 5, 6, 7, 8, 9 I will take. First one A. A, B, A, B, A, B, 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 A, finally B. Okay. So, till 8 we will get here. Sorry, till 9 here we will get. But after that 10 we will not get. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. The length of the string 9. So, 9 should be accepted. Now, we will see. A, B, A, B, A, B, B, A, B. So, instead of taking this, let's check with number only. 1, 2, 3. 3 is accepted. 4, 5, 6 is accepted. 7, 8, 9. 9 is accepted. 10, 11, 12 is accepted. 13, 14, 15 is accepted. Like that, every time to the number 3 is added, hence it is ending up with the final state. Hence the string is accepted. Now the logic is done. Now check according to the definition of DFA. Each state should have a transition with A, B. Q0 is having transition with A, B. Q1 is having transition with B, A. Q2 is having transition with A, B. So all states are having transitions with A, B. Hence, the DFA what we have designed will accept all the strings of length which are divisible by 3 or multiples of 3. So, modulus W, mod 3 if you take, we will get remainder for all these numbers. Other than this, we will get 1 we will get. We will not get 0. Other than these numbers which are not multiples of 3, we will not get the remainder as 0. So, hence, the logic of this particular question is understood and we have designed the DFA, right? Hope you understood how to design a deterministic finite automata for a language which accepts the string of length that is divisible by 3. Hope you understood. We will discuss further more problems on this type of regular languages in the upcoming videos. Thank you for listening. Bye.